Basics of binomial theorem then. I've got three very basic examples on the board. I'm not going to explain right from the very beginning how this pattern that I expand out, how that is developed and where it comes from. I'm just going to do the examples so you get plenty of practice of looking at how this is expanded out. So, first one, x plus 1 all to the power 5. It's the same as, if I expand out, I'm going to get the following. I'm going to get x to the power 5. Power 5 is the bracket, so the first term will be x to the power 5. First term to that power 5. Plus, next we now introduce the choose values. If it's power 5, we have 5 choose 1. The first of the choose values, 5 choose 1. Then we have the x, and the power of the x goes down by 1. So power 5 now becomes power 4. We also multiply it by the second term, whatever it is, and in this case it's a positive 1. And the first time we introduce that, it's going to be power 1. Those two powers there must add up to the 5, or the original power 5. So 4, 1, make 5. That's the first of the choose terms. Plus, then we have the second of the choose terms. 5 choose 2, x goes down from power 4 to power 3, and the plus 1, which comes next, goes up from a 1 to a 2. Plus, we then have the third choose value, which is the actual 1, 2, 3, fourth term of this expansion. 5 choose 3, x goes down to a squared, and then you have plus 1 to the power 3. Plus, then we have 5 choose 4, x goes down to power 1, and it's plus 1 to the power 4. And then finally, plus the very last one, the x's now disappear, and the second term you have is simply plus 1 to the power 5. Of course, if you wanted to, you can just write down plus 1 to the 5. You can drop the plus inside the bracket if you want to. So that's the basic expansion. Okay, let's tidy up. This is equal to x to the 5, that stays the same. 5 choose 1, remember how we work these things out. 5 choose 1 is just 5. So it's 5 times x to the 4 times 1. So that's 5x to the 4. Plus 5 choose 2. If you remember 5 choose 2, I'll just do it down here. 5 choose 2 is the same as 5 by 4 over 2 by 1. Where that comes from and how it links to the factorial notation we talked about at the time I did binomial doesn't really matter, as long as you understand how to work it out. 5 by 4 over 2 by 1. If you work that out, you're going to get 10. That's 20 over 2, 10. So we've got 10 there, multiply by x cubed, and then plus 1, if you square it, you get 1. So you're going to get 10 x cubed times 1, which is obviously just 10x cubed. Plus, then 5 choose 2. Now if I wanted to, 5 choose 3. 5 choose 3 I could work out by saying 5 by 4 by 3 over 3 by 2 by 1. But if you remember, we have a symmetry of coefficients with the binomial choose values, and the 5 choose 3 from symmetry is exactly the same as 5 choose 2. So that can be replaced with exactly the same thing as we had for that. That is the same as that. So 5 choose 3 is the same from symmetry as 5 choose 2. The 3 and the 2 go together to make a 5, if you notice. That's how this symmetry of coefficients of choose values works. So if 5 choose 2 was 10, 5 choose 3 will also be 10 times x squared times plus 1 cubed, well that's just plus 1, so it's 10x squared. Next, 5 choose 4. If you remember from the symmetry of coefficients, 5 choose 4 is the same as 5 choose 1. They are the same thing. The 4 and the 1 make 5 if you remember. So 5 choose 4 is the same as 5 choose 1, which is just 5. So we get plus 5, and then it's x to the 1, which is x, and then plus 1 to the 4, which is 1. So you get 5 times the x times 1, which is just 5x. And then finally, of course, you get plus, the plus 1 to the power 5 is just plus 1. And that's it. That's the expansion, x plus 1 all to the power 5. That needs to be sort of automatic. You don't have to think about that. In exam papers, usually that process is used somewhere along in the question, along the way to working out perhaps a more complex question. Okay, that's the first one. If I now just quickly, I'll make some space, get rid of that one, and I'll do this one a little bit lower so you've got more space. to see what's going on. I'm going to do x plus 1 to the 6, and I'm going to do it very quickly. Here we go. First of all, x to the power 6 plus, this time because it's power 6, it's 6 choose 1, not 5 choose 1, 6 choose 1. The x goes down to a power 5, and then it's a plus 1 to the power 1. Plus, next, 6 choose 2, it's x to the 4 now, power goes down from 5 to 4, and it's plus 1, and that becomes, instead of 1, it rises to a power 2. Plus, 6 choose 3, x falls to a power 3, plus 1 rises to power 3. At all times, notice the 4 and the 2 make 6, 3 and the 3 make power 6, 6, 5 and the 1 there makes 6. Plus, 6 choose 4, x falls down to power 2 from power 3 to power 2, and then you have plus 1 rises to power 4. Plus, then you have 6 choose 5, x now falls from power 2 to power 1, and the plus 1 goes from power 4 to power 5. And then finally the x's disappear altogether, and you just get plus 1 to the power 6 as your last term. Okay, let's just tidy this up. X to the 6 plus 6 choose 1 is just 6 times x to the 5 times 1 is going to be 6x to the 5 plus 6 choose 2 is 6 by 5 over 2 by 1. That's what 6 by choose 2 is. That's 30 over 2, that's 15. So that's 15 times x to the 4 times 1 squared. So that's 15x to the 4, because 1 squared is just 1. Plus 6 choose 3. 6 choose 3 is 6 by 5 by 4 over 3 by 2 by 1. Okay, you can multiply it all out if you want to, but easier to look for cancelling. 3 2s are 6, so they can cancel. You're left with 5 by 4 over 1. That's 20 over 1, which is 20. So 6 choose 3 is 20. X cubed times 1 cubed. So that's just x cubed. Let me make some space here, get rid of this. Next one, we've got 6 choose 4. Well, 6 choose 4 from symmetry of coefficients of the choose values is the same as 6 choose 2. 6 choose 2, if you remember, was worked out to be 15. So that is plus 15 x squared times 1 to the 4. That's just x squared. Plus, then we've got 6 choose 5 from symmetry of choose coefficients. That's the same as 6 choose 1. 6 choose 5 therefore is 6 times x to the 1 times 1 to the 5. So you're just going to get plus 6, x to the 1 is x, and then 1 to the 5 is just 1, so it doesn't change anything. So it's just plus 6x. And then finally, you got plus 1 to the 6, that's just plus 1. And that's it. That's the expansion of x plus 1 to the power 6 in its entirety. That's the full expansion. Okay, one more of this in this short video, and I'm going to then, in the second video, make things a little bit more difficult. Okay, let me make space of all that, get rid of all of that, and I'm now going to do one more full expansion, and I'm going to do x plus 1 to the power 7. So just so you get used to the process that we're going through. So power 7, you're going to get x to the power 7, first term, plus power 7, 7 choose 1 as the first choose term. Power of x goes to a 6, it's a plus 1 again, plus 1 to the power 1 then. Plus 7 choose 2, x goes down to power 5 from 6, and the plus 1 rises to power 2 from a power 1. Plus 7 choose 3, x falls to a power 4, and then the plus 1 rises to power 3. Plus, okay, remember at all times, because power 7, these two powers must add up to 7 at all times, as it is doing, as you can see. Next, 7 choose 4, x to the 3 falls from power 4 to power 3, the plus 1 rises from power 3 to power 4. Plus, then we've got 7 choose 5, x now falls from a power 3 to a power 2, plus 1 rises from a power 4 to a power 5. Plus 7 choose 6, x falls to a power 1 from a power 2, and the plus 1 rises from power 5 to power 6. Plus, now the x's disappear altogether, and you're just left with the second term plus 1, which goes up to a power 7. There's the basic expansion. Let's work out and simplify now. So we get x to the 7 is the first term, plus 7 choose 1 is just 7. Times x to the 6 times plus 1 to the 1. So you're just getting 7 times x times the 1, which of course is 7x. Plus 7 choose 2, side sum. 7 choose 2 is 7 by 6 over 2 by 1. That is the same as 42 over 2, 21. So this is 21, and it's x to the 5 times plus 1 squared. So it's just 21x to the 5. Plus 7 choose 3. Well, 7 choose 3 is 7 by 6 by 5 over 3 by 2 by 1. Okay, let's cancel. 3 times 2 is 6, cancels that 6. That leaves you with 7 5s are 35 over 1. So what you've got is 35, okay, 35, 7 choose 3 is 35 x to the 4 times 1 cubed. So 35 x to the 4, so that's that term there. So 35 x to the 4 times 1, 35 x to the 4. Plus 7 choose 4 next. Well, 7 choose 4 is identical from symmetry of choose coefficients to 7 choose 3. They are the same thing. So we've just worked out 7 choose 3, it was 35. So we've got another 35, this time it's x cubed times plus 1. So it's just 35x cubed. Plus, we've got 7 choose 5. Well, 7 choose 5 from symmetry of choose coefficients is the same as 7 choose 2. 7 choose 2 was 21 if you think back. The 1 to the third term, 7 choose 2 is 21. So we've got 21 now, okay, for 7 choose 5, and then x squared times 1 to the 5. So it's just 21x squared. Carries on. Plus 7 choose 6 is the same as 7 choose 1 from the symmetry of coefficients of choose values. 7 choose 1 is just 7. 7 choose 6, x to the 1 times 1 to the 6. So it's just 7 times x times 1, which is obviously 7x. Plus, and then plus 1 to the power 7 is just plus 1. That is the full expansion all the way through of x plus 1 to the 7. Because it's a very basic example where both these values in here involve a coefficient of 1, 1x and plus 1, when you do the expansion, you will find for all of these, when you just have an x plus 1 in the bracket being expanded, that you'll have a perfect symmetry of coefficients because it only depends upon the choose values, and there's always a symmetry of choose values. So you get a 1 there, and there's a 1 there, a 7 there, and a 7 there. I've just spotted here, I don't know if you if you would have noticed when I was doing this, x to the 7, x to the 5, x to the 4, that should have been x to the 6, so apologies for that if that confused anybody. So x to the 7 plus 7x to the 6 plus 21x to the 5, and you've got the two 35s there, then the 21 symmetrical, and the 7 with the 7, and so on. So we've got a perfectly symmetrical coefficient set up there because it basically depends only on the choose values, and that will always happen when you've got an x plus 1 in the bracket. Things change slightly. I won't do this one in this short video, I'll do it in the next video, but we've got something like 1 plus 2x raised to a power 7, something like that, because that now is no longer a 1x, you'll find that we don't get the expansion coming out to have a perfect symmetry of coefficients. The choose values will be symmetrical, but when you expand it, because there's a 2 there, you don't get the final expansion to have a perfect symmetry of coefficients, as you'll see. But that's for the next video.